Hello and welcome to this session on the binomial theorem, our fourth session. And in this short session we're going to be looking at a particular type of question where we're asked to find products which involve at least one of the two parts of the product being a binomial expansion. And they're a little bit tricky and require a little bit of thinking about how to plan your approach. So I thought I'd give you just a few examples just to get you started. So here's a typical example. Use the binomial theorem to expand and simplify 5 minus 3x times 2 minus x to the power of 4. Now in this case, we're going to have to basically do all of the work. So I'm showing you this example as this is the worst case example of a binomial expansion as a product. And here, the best thing to do is to do your binomial expansion first. So we know that 2 minus x to the power of 4, just using the formula underneath, is going to be 2 to the power of 4 plus, and then 4c1, which is 4, 2 to the power of 3 times minus x, and then it's going to be plus 6 because that's 4c2, 2 to the power of 2 and minus x all squared, and then back to 4 because we're at 4c3 now, times 2 minus x to the power of 3, and then finally it's going to be minus x to the power of 4. Squeeze that in there. So my result there, I'm going to put this in brackets now, is 2 to the power of 4, which is 16. 4 times 2 to the power of 3, 4 times 8, that's minus 32x. It's negative there because I'm multiplying by minus x. 2 squared, 4 times 6, 24. It's going to be positive because I'm squaring a negative x. So plus 24x squared. Next term, 4 times 2, 8. And of course this will be negative because I'm cubing a negative, minus 8x cubed. And then finally plus x to the power of 4. And I'm multiplying all of that by 5 minus 3x. Now my only tip here is that when you write out your result, to make totaling easier, write it in columns. So multiplying everything by 5 first, I would end up with 80, 5 times 16, and then 5 lots of minus 32 is minus 160x, and then 5 times 24 is 120x squared, 5 times 8, I'm going to have minus 40x cubed, and I'm going to have 5x to the power of 4. And then I'm going to multiply everything now by minus 3x. So my first multiplication, minus 3x times 16, will give me minus 48x. So I'm going to write that in the x's column. And then let's keep going with this. Minus 3x times minus 32. And minus times a minus is plus. So this will be plus 96x squared. Then I'll go negative again. 3x times 24x squared, I'm going to have minus 72x cubed here. And then we'll go positive again, minus times a minus, 3 times 8, 24, x to the power of 4. And don't forget the last term, 3x times x to the 4, and it's negative, will give minus 3x to the 5. And then to get my final solution is just a case of totaling this up. 80 stays on its own. Minus 60 minus another 48 is minus 208x plus 216x squared minus 112x cubed plus 29x to the 4 and minus 3x to the 5. Now, nothing too complicated there, but notice the way that I laid that out to make it nice and clear and easy, and to minimise the chances of making silly mistakes when I did my calculations. So that's the worst case in terms of the amount of terms I'm going to need to multiply out. But we need to be smart about finding an answer in a quick way. So in this case, second example, it says find the coefficient of a to the power of 4, b to the power of 3 in the expansion of a minus 3b times a plus b to the 6. Now I could do what we just did in the earlier example, and I could multiply absolutely everything out and then just hone in on the particular term with the coefficient of a to the 4, b to the 3. But it really will take a little bit of time. So here's a quicker way of doing this, and that is, well, let's first of all rewrite this expression as this is the same as saying a times a plus b to the 6 minus 3b times a plus b to the 6. Now, I want the result from each of those multiplications, when I multiply by a and when I multiply by 3b, I want the end result to give me a to the power of 4, b to the 3. So what I need to think about here is I want the term from this first expansion where it's a to the 3, b to the 3, because I'm going to multiply it by a. So I'm going to end up with a to the 4, b to the 3 there. And in this second expansion, I'm about to multiply by 3b. So I would want the term with a to the 4, b to the 2, because I'm going to multiply b, which would make it then b cubed. Now, using my binomial formula from below, I know that in front of the a cubed, b cubed, r must be equal to 3. And n is 6, so I would have 6c3 in front of this particular term. And the second one, I would have 6c2 because my value of r is 2. So those are the actual terms that I'm interested in from a plus b to the power of 6. And I'm multiplying by a there and 3b there. So if I just do the maths now, that's inside there. 6c3 is 20, a cubed, b cubed, minus 3b times 6c2 is 15, a to the 4b squared. Multiplying all of that out, I end up with 20 a to the 4b3 minus 45 a to the 4b3, which gives me negative 25 a to the 4b3. So my coefficient, remember the question asks me for the coefficient, is minus 25 there. Now that's a lot quicker using that method than expanding everything out. Of course, if you expand everything out, you will get an answer, but you will also lose a lot of time that could be spent gaining marks elsewhere in your paper or test or whatever you're sitting. Final question then. So the worst of the worst, this time we've got 3 terms that we're going to multiply our binomial expansion of 2 plus x to the 5 by. But our approach should stay exactly the same as the one that we've just done. So let's rewrite that as it's 1 times 2 plus x to the 5 plus 2x times 2x plus 2x to the 5 minus x squared times 2 plus x to the 5. And I'm looking for the coefficient of x to the power of 4. So in this first term, I'm going to be multiplying by 1. So I will want the term that results in x to the power of 4. In the second one, I'm going to multiply by 2x, so I would want the result, or the term, from the expansion that results in x to the 3. And in this last one, I'm going to be multiplying by x squared, so I would want the term that results in x squared, because x squared times x squared would give me x to the 4. Now, using my binomial formula below, to result in x to the 4, that must have come from, well, r is equal to 4 and n is 5, so I would have 5c4 2 to the power of, well, it would have to be to the power of 1 because x is to the power of 4. So in this case, that would be my term that I'm interested in. In the second case, x cubed would have to go with 5c3, r is equal to 3, and this would be 2 squared because x is cubed, so 2 must be squared in order to add up to 5. And I'm going to multiply that by 2x. And in the final case, I want the term for x squared, so I would end up with 5c2 and 2 to the power of 3 here because x is squared, so 2 must be cubed. And I'm going to multiply that by minus x squared. Now, that is so much quicker and easier than having to expand absolutely everything out, which is doable, but it just takes up a lot of time. So let's do the maths there. So the first case, 5c4 is 5 times 2 is 10, multiplied by 1. I'm going to end up with 10x to the 4. In the second case, 5c3 times 2 squared and then times 2 again would give me a result of 10 times 4 is 40 times 2 is 80x to the 4. And then finally, 5c2 is also 10 times 8 is 80. And it's a minus here because it says minus x squared, minus 80x to the 4. So my end result here would just be 10x to the power of 4, because this one and this one will disappear. Now, I don't think that's too difficult. It's just good to be smart and to find a quick way to answer questions that could otherwise take up a lot of time in solving. Those are products of binomial expansion. I hope that you found that useful. Thank you for watching. Don't forget to like the video, subscribe to my YouTube channel, IB Maths Intense, and of course tell your friends I'm here. Drop me an email, ibmathsintense@gmail.com, if you've got particular requests or things you'd like to know, or if you've spotted any mistakes that I've made. But in the meantime, take care and enjoy your maths.